My name is Dr. Shobhu Sachisyan. I am the Dean Research and Development of JIS College of Engineering. But herein I am here to talk about my physics courses. Okay, I am basically a physics teacher. I do take physics in the classes in the BTech courses, first and second year. So now here I am talking about my second year courses, which is called Physics 2 courses. Now, second year course in Physics 2 is separate for separate branches. For computer science and IT, bouquet is something. For mechanical, civil, it is different. For electrical, electronics, all are different. Obviously, they are learning in a different semester. Now, it is stream specific. It is as per the requirement of your own subject. Okay. Say in the computer science and IT syllabus, we have added the latest computation like quantum computation. Like the applications of latest materials called nanomaterials, how the storage and display devices works. These things are not so much connected with the mechanical and civil engineering, who are also learning physics 2 in this course. So we have kept courses like the ultrasonics, okay, which is applied in mechanical and civil. The concept of building acoustics for civil, which is not needed for you. So basically, we have made it stream specific. We made a thorough analysis of the requirement of your course from your department, from your alumni, from the existing student. We made a survey. Based on that, course objective and outcome was framed, and let me present the same now. Now the course objective of this Physics 2 course for CSE and IT student is that is to introduce topics, okay, is to apply quantum mechanics for learning the latest of computation called quantum computation, learn quantum logic gates. Is to, as a student, you get comprehend about the hardware sectors of your devices, okay, the storage, display part, and also the latest storage devices. You know, the entire electronics is moving very fast, and that is because of the revolution in semiconductors and now the nano devices. Okay, so an introduction to that. So that will be another objective of this course. And also this entire communication system, okay, it's based on the electromagnetic theory. Okay, so we'll also provide you some glimpses of electromagnetic theory, because later on you have got courses on the analog communication and digital communication. Okay. Now the major course outcome of this Physics 2 course for CSE and IT student is that after undergoing this course, you will be able to explain the electromagnetic theory with your basic knowledge of electrostatics, magnetostatics and electromagnetic theory. You will be able to explain the most modern computing devices using the latest idea of quantum mechanics and quantum mechanics principle. You will be able to explain the operation of the most modern storage devices, how it evolved from the magnetic storage to semiconductor devices. You will be able to judge the requirement of the latest material for the purpose of computing, for the circuit design, and for the storage material, that is the ideas of nanomaterials. Okay, so let us, and you know, this is closely connected with your own program, so you can get that in the course outcome, program outcome mapping also. On the screen you can see the various modules that are present in this course, and you can also see the module that we will be starting with. We'll start with one of the promising modules of the course, as well as you can also see the topic that we will begin with. And in this particular class, whatever we will be focusing on, the related prerequisite, what is the objective of the class, and you know, if at the end of the class you're supposed to get something from me, that is the outcome of the session. So that session outcome also you can see on the screen. Hello students, how are you? Very good morning and warm welcome to my class. Have you heard a very recent bad news? Yes, very recent bad news. No idea. I'm not talking about the COVID-19, its pandemic. It has already devastated our life. Okay, our life is no more like the previous one. Now, everybody asks you, now think about which colored mask we'll use, okay, in our face. How many sanitizers and spray we should keep in our pocket. Okay, this has been the main topic. So this has already devastated. So that is no more the bad news. It is a part of our life now. Any more bad news have you heard? Yes. Yes, my dear boys and girls, I am talking about your own course curriculum. Okay, in this odd semester, in your third semester courses, do you know? Have you seen your syllabus, your curriculum? What are the papers there? The bad news is there. Bad news is there. Yes, right. Guess now. The bad news is that to you it may be bad, and but for me it is a great opportunity. Okay, that physics is back in your curriculum. I'm talking this because by looking at your last year performance, your odd semester physics one result was may not be praiseworthy. Okay, some of you have been exceptional, but in general it was. I was not happy with that result. I'm not blaming anybody. It may be because of the system. Okay, we have taken so much of time. Your classes begin in the late August, and in the end September there was puja holidays. After that, so you hardly get 1 month of time, and when you came back, you see the examination notices there. So you maximum get 2 months of study, and the course content was almost the course content somebody learns in physics honors courses in your first year courses. So the degree of the course on the type of topics that is presented in first year topic, you cannot reduce that, because without that your future semesters or some other top papers are connected with that idea. So you have to keep that idea. But problem is that because of the lack of time, many of you could not cope up or could not got to that level of learning in first year courses what I anticipated. So it was maybe like a bad dream to you. So my job is to make this dream a bit sweeter. Okay. I'm happy that I have again got the opportunity of interacting with you, offering a course, a beautiful course like physics, and moreover, the course content is so designed. Okay, it will only enchant you to its next level, because we have kept the topics which are most modern topics of technology. We have kept quantum computation, the latest of computation, the highest level of computation you can even dream. Okay, this present age is the age of data, age of computer science and IT professional. So this in this age actually we have kept a very most modern topic of this dealing with data. Okay, the quantum computation is the Google has come up with its quantum computation recently. So what is a quantum computer that you do not know? You only heard it this term. So in physics, the fundamentals of the quantum computation learned in our physics course. So you have to learn. If that's so, you have to learn this topic. We have kept the syllabus has been designed in such a way. It has been, I should say, it has been tailor-made for you. It has been designed only for you. You are the priority. You, my students. We are undergoing a system that is called outcome-based system. The essence of the outcome-based education is that I will tell you what you are going to get out of this course. Okay, what would be your attributes after you attend my course? And those attributes has to be in line with, as a computer science or IT professional, whatever you wish, that I have to provide. You are not learning physics honors. So what we did, we have made a thorough survey from your department, your teachers, your seniors. They are our alumni actually. Even we have taken industrial inputs. We have taken the inputs of the board of studies member of our physics, and also your core department, computer science and IT board of studies senior professors. So based on their input, we have made the course. So it is tailor-made for you. It is only for you. Your friends in mechanical engineering and civil engineering are also studying physics in this course, in this year, in this semester. But their course content is altogether different. Why? The reason is very simple, because a mechanical student have to learn the details of how he has to go work on manufacturing sector. He needs to know the details of the matter in more detail, whether a structure is defected or not, how we can do the testing of any crack in a solid structure. So he has to learn ultrasonic sound. Civil friends have to learn that much also. Mechanical friends, crack is the crack in a solid structure of, say, metallic sheet in a foundry, and your civil students has to go for the similar testing, but there are a concrete building. So both of them have to learn ultrasonic sound. Civil engineering friends will learn building acoustics, which you don't have to learn, because your job area of application is different.
So we have kept the topics in line with that only. We have kept most, as I mentioned, most modern computation, quantum computation. We have, we have, you see, if you look at the history of computer science in general, there has been a revolution. Okay, 1940s and 50s, the type of computer people have been using. At that time, it was called UNIVAC, etc., because it was made of vacuum diodes. Okay, because it's, everything is all the all the computation you are learning now, or you'll be learning in this semester in your computer architecture courses also. Entire algorithm that you learn, you are having papers on data structure, algorithm, etc. That is based on classical computation. Classical computation means the basic mathematical background is Boolean algebra, 0-1 logic. So you have learned binary system. Binary means two numbers, 0 and 1. Y means 2. So whatever you do, whatsoever be the, you realize those 0 and 1 to voltage values. You learn logic gates a bit. You manipulate them through another various logic gates. But if you look at all those manipulation, you have got no numbers apart from zeros and ones. So entire logic gates, everything is based on that logic, and it operates basically off on high-low technique. This is attained through transistor. This is called CMOS technology. Now now it is CMOS, but initially it was big vacuum transistor. Now there is a historical revolution in the semiconductor electronics from 1965, when Gordon Moore told about a law that this semiconductor electronics will develop rapidly. After every 18 months, the revolution will come. Okay. So now, because of that, what is happening? More and more transistors are now jam-packed together, and your system size, your computer size, your device size is very low now. Or all our mobiles are like computers. Okay, you can do anything. So this historical revolution has been taken place, and what you have done, you have made each logic gate size very small. So this revolution has taken place, but this revolution has not done by you, the CSE and IT people. It has been done by the physics people, done by the electronics people. The history of semiconductor has changed the entire computer industry. The Silicon Valley, you have heard, na? So it's a huge change has taken place. Now the latest technology is nanotechnology, where you are using a molecule to give you the transistor action. And in a quantum computer, all that type of manipulation people have to do. So the things are very interesting. So I request you to look into the details of the topic, enjoy it. And if you are staying in that microscopic world, in this new computing world of the quantum computation, or you see, if you are think about a computer itself, one is the software part. Okay, they were coding part that your code departmental teachers will tell you. But apart from that, hardware part is there. Okay, I was talking about the transistors, the CMOS technology, its evaluation that has been done by the physics and by an electronics. But as a student of computer science or IT people, you have to learn that how this has taken place, the latest of devices. So you have kept some devices like that which will be utilized for your hardware section. So you have kept a bit of ideas about also about displays. Okay, now we are using all LED LCD displays. Earlier you have been using CRTs, the cathode tubes or cathode monitors. So there is revolution is there also. Revolution is there in the storage unit also. Earlier we used to store in magnets. Now we are using semiconductor storage. In digital circuits, you learn about flip-flops, which are basic storage of semiconductors. So now storage is very important. Okay, any hard disk of your computer is like few TVs. Okay, 2 TB hard disk you get if you have to get a new computer. So where you store? Their semiconductors are used as storage. So that revolution will also learn. So what I'm trying to tell you, we are trying to keep topics which are in alignment with your own requirement, course requirement. So let us go through the topics. It's very interesting. Okay, just for your information, this quantum will. Okay, initially I'll talk about in physics 2 course in general. Okay, and we'll begin our journey with quantum mechanics 2. And you know me. Okay, this is my brief profile. Okay, I don't have to utter this. And you see why you are learning this course. This I have presented separately also. This course objective and outcomes you should note. Now here comes the chapter 1. Okay, I will begin our journey with quantum mechanics 2. Okay, actually today's class will end up with the idea of quantum mechanics too. Okay, it is basically the applications of whatever you learned in first year. If you look at the first year quantum mechanics course, there I also told you that is quantum mechanics 1. So first year actually, why those, you know, this, what are the meaning of these beautiful pictures? Those beautiful pictures, okay, you see it is becoming, you see these are basically electron orbitals. S orbital, you see it's like this is D orbital, this is S orbital, this is P orbital, okay. But okay, I told you in your first year case how this concept came up. These are not electrons, okay. These are actually probability of finding the electron. If it is D orbital or S orbital, that means you are thinking electron may be present over a spherical region like that, okay. So these are called probability waves of electron or wave nature of a matter electron. So what is this probability wave, or what does it mean by the wave nature of matter? That I have told you in your first year days. Okay, so we had a quantum mechanics 1 course where I told you about the entire theoretical development, how everything has come up experimentally, because if theory proves anything or theory gives an output, so from that those ideas are now theoretically you are supposed to know them. Okay, practically I do not know how much you have remembered. I'll make you remember, don't worry. Now all those learning of first year is expected to teach you the lesson that electrons may be wave like, that wave is a wave of probabilities. Now time has come in this semester, we'll apply those ideas in real physical problem. Or one problem maybe, suppose you are explaining the action of a diode semiconductor, okay, so that we will be explaining through these new quantum ideas. Variety of problem will come, so these are all application time now, okay. So that we will do that, but before that I think I have to put a bit of trouble for you. I have to tell you the fundamentals of something that I told you in first year courses, okay. And this is something I was talking about initially. You see that is those arrows, you know, you see beautiful pictures are there, okay. Quantum gate, you see up, down, you know what does it mean by up, down? Who has got up, down? Well, a spin. So electron spin is going to represent a bit, just like 0 and 1 represents the classical bits. Here spin up and spin down will represent quantum bits. Now spin is the magnetic property. I hope you know a bit. You see few fractions are coming, okay. So if you rotate the spin, okay, you can generate number of qubits. I will discuss it in little. Qubit is quantum bit, just like we can say bit in the binary system. In quantum mechanics, it is called qubit. Qubit is a quantum mechanical state of an object, okay. So what is a quantum mechanical state? I have told you a bit in first year days. I will make you remember. So what I am trying to tell you, this entire new type of computation that is coming in a big way, okay. Already Google has got quantum computer. Quantum computers I had used for high-end computation purposes, okay, where massive data dealing is there. Suppose you want to simulate how a Mangalyaan will reach to the planet to the planet, okay. So how do you calculate it? You have to simulate the entire thing. So a lot of calculation will be there, how that it will move. So all these dynamics you have to do. So all this needs a lot of calculation. That needs high-end computation. So as a professional of computer science, you have to provide that high-end computing tools, either through coding or through this hardware arrangement. This hardware arrangement is the latest hardware arrangement is quantum computation. Quantum computing arrangement is altogether different. Algorithms are all different. We will discuss it, okay. I tell you, keep patience. We'll talk about this. You see, logic gates will be different. These are not AND or NAND nor, okay. Logic gates are different because here I have to manipulate spin of electron to realize a quantum bit. Up spin may be one bit, down spin may be another bit. Beauty is that quantum mechanical laws will tell you, I will discuss it, that it is not just up and down. In between, there are many more spin rotation are possible. Everybody of them will be a qubit, which is unlike to normal binary system where you can get only two numbers, zeros and one. So these beautiful things are waiting for you. This is the latest computation. You will be enchanted to see, okay, where the level of computation that has reached now. Obviously, algorithms will be all different. Okay, Schwartz algorithm is used, one of the popular algorithm. Okay, your latest machine learning also you can do with quantum computers using this new types of algorithm. So you see, the entire data science and computing technologies are rapidly evaluating. A new technology has come up called quantum technologies. Under these, all these things will fall, where everybody has to work together. Myself as a physics professional, you as a computer science IT professional, we have to work, because all of us are working for mankind. We want to give robust computing tools, maybe through software, maybe through hardware. So you have to work in hand, and this is something waiting for you in first year. In this second year course, we'll talk a bit about this. Okay. And I request you to make higher studies. There you can take this as a separate paper. You can do, it is a live area. You can do some research work also even. Okay. So a lot of areas are there. We have got the latest of the virtual NanoLab software in our lab, where we can jointly do some coding also. So you can do some hands-on experiment here also. So very beautiful topics are there. So because it is day one, I am telling you all these possibilities. Now the next chapter that is included in your course is called statistical mechanics. Statistical mechanics is basically, what statistics comes not for one object or two objects. It comes for many objects. Suppose I've got, you see the left hand side picture, you see they are basically gas molecules in a container. Okay, a lot of gas molecules. So that is a classical example. Similarly, in an electron, there will be a lot of electrons moving, electrons in a metal. So there, the way you have to, just like if you compare with your classical knowledge, suppose I've got one object moving, two object moving, you have got your Newtonian ideas. But if you have got, say, crores of object moving, you don't use Newtonian concept. The level of mechanics has to be modified. That is called statistical mechanics in general. Classical mechanics problem also, just like gas molecules in container, you have to learn classical statistics. For large electrons in a metal or photons, you have to use quantum statistics. And actually half of the world is divided in two parts. One half of the particles available in universe obey the voice of an American scientist, Enrico Fermi, and the half is called Fermi-Dirac statistics, and other half obey the voice of an Indian scientist. Do you guess who is that Indian scientist? He was living in Kolkata near to our science college. Okay, he was in Dhaka University for a long time, and he is none other than Professor S.N. Bose. Okay, half of S.N. Bose, Satyendra Nath Bose. His idea, Bose-Einstein statistics, actually his major idea, okay, is followed by half of the world. Okay, that's why they are called Bosons. Okay, it's a great tribute to an Indian. Nah? Half of the world belongs to an Indian. Okay, just think, dare to dream. Half of the particles in the world is in the name of an Indian. It's, okay, bosons they are called. A piece of light, photon, is a boson. A piece of sound, phonon, is a boson. And electron, proton, neutron, they are called fermions. Okay, you have heard about Fermi level. So you learn this in detail. Okay, this is a beautiful topic. Okay, you'll be perplexed. It is so beautiful. Okay, now another topic after that, it is more classical actually. You have to learn a bit of storage devices. Storage devices are there. You see, historically you have been storing magnets to store data. If you have got an older tape recorder at your home and those tape, you will see there are brown colored tapes are there. That is a magnetic coating. But not all the magnet can store data. Suppose I take a bar magnet and still my name is Shobhoj. Will it store data? Never. We need special type of magnetic material. They are called hard magnet, soft magnet, etc. You learn them in this course also. So magnets have been storing data like CD-ROM, even the earlier ATM cards. Okay, there was a brown chip. Now you have got chips available, semiconductor chips. Now even the metro tickets. Now due to lockdown, all the things are closed. When metro reopens, and if you experience metro tickets, it is a magnetic ticket. Okay, so magnets are, what is done inside the ticket? Some data is stored. Okay, and try to remember metro ticket data. Suppose you it is a read-write device. Okay, when you are getting the ticket, something is written there, and when you are going out, that is off, like that. Okay, so quick read-write option should be there. So we need some type of magnetic material where you can make quick read-write. But some other, say suppose I have got a CD drive, so that will be permanent storage. So that we need some other magnetic material where read-write option will be, where the level of storage will be more, it can store for a larger time. So various types of magnetic materials are there. I think this must be knocking your mind, okay. But now it is for computing purposes, all our hard disk, okay, they are not magnetic storage. You use semiconductor to store data. So that you have to learn. Your pen drives, okay, now it is almost one TB pen drive, one TB pen drive is available, okay. Not at too much of high cost. What people are doing, you have to use certain material to store data. Semiconductor has been used, now nanomaterials are coming for storing data. So quickly everything is changing, okay. So you will get a glimpse of that, because you know storage is an asset. You see, how about cloud computing, you'll be learning later on. Google Cloud, all our database are stored in Google Cloud, okay. You put Google Photos, everything. Cloud means is a huge storage. Your emails keeping a lot of data, huge storage is there, okay. So storage is an issue. How you can scientifically enhance the storage power, okay, all these things are important. You'll get an idea. Now obviously, if this is the 50% of your syllabus, that is about the latest of the materials, like the application of the latest of the mechanics called quantum mechanics, quantum computation, statistical mechanics, which are almost most modern and high-end topic. But there are a few classical topics also. Classical means proposed before 1900, like Maxwell's idea, Maxwell's equations. Now these things are important because you have to explain the journey of a wave called electromagnetic wave through a medium. You will be learning a topic called electromagnetic communication, analog communication, digital communication. You see, our communication technology is digital now, but in general, this everybody involves a technique called modulation, where you mix one signal with another signal. If you think in terms of classical communication, suppose somebody is singing at a radio station, so how that signal will go from the radio station to your home. The song itself is an audio signal. If I say I'm using audio wave, mechanical wave. Suppose I make it electrical by some technology, but it does, even if it does not have enough power to reach from Kolkata to maybe Kalyani, a long distance. So if you have to send it from Kolkata to Kalyani, suppose from an FM station, one Kishore Kumar song is emitted. Now it cannot take Kalyani local to come from Kolkata to Kalyani. It has to be sent from Kolkata to Kalyani in some other technique. What is the technique? You have to put that audio wave on a radio wave. Okay. So that radio wave is an electromagnetic wave. That is called a carrier wave because it has got more power than the audio wave. Just like you take a train to come from Kolkata to Kalyani, because you do not have enough power to reach from Kolkata to Kalyani by walking. So train is your carrier. Here also audio signal needs a carrier, and that is a radio signal or electromagnetic signal. Now electromagnetic signals people have been using, how it goes, what is electromagnetic signal. So Maxwell has got 4 laws to describe that. First law is related to electrostatics. You have to learn in detail. Maybe learned a bit in 12 standard courses. The second law is related to the magnetostatics, that is the effect of magnetic field due to a steady current. Third law is related to the electromagnetics, that is production of electric field due to change in magnetic field. And fourth law is related to electromagnetic theory, that is the Maxwell's correction, that tells us that a change in magnetic field can produce the a change in electric field can produce the magnetic field. So the third one is called Faraday's law, which tells if magnetic field changes, I will get a EMF current, a voltage. And the fourth one is Maxwell's correction, okay, which actually explains many things, the action of capacitor, etc. You learn it, okay, how capacitor acts. Suppose capacitor means you have got kept nothing there, it may be here also. So how current passes. So all those stories are actually explained through this idea. There is the idea of displacement current. Maxwell has made some correction into that discussion. But at the end of the discussion, it tells that I've got a variable electric field, I will get a magnetic field. And if you mix the last two equations, you'll get the wave equation that will tell you how electromagnetic wave will pass through free space, through medium. All those stories you can learn. And another connected concept is that which will be applied in your, particularly in your LCD displays, is a process of polarization. You know, electromagnetic waves normally, it's a mixture of electric and magnetic field, you possibly be knowing, okay. And this is an electromagnetic wave, it's a mixture of electric and magnetic field. And you see here it is vibrating, electric field is vibrating in a particular direction shown by the blue arrow, and magnetic field is vibrating in another direction shown by the red arrow. Now this blue and red together makes this particular electromagnetic wave. Okay, and you can see there it's so beautiful that electromagnetic wave is traversing, but in general it is just perpendicular to the x-axis. Okay, now in general from a point source, if you have got a source of light which is also an electromagnetic wave, you know it will be moving in all possible direction, entire 360 degrees, so electric field plane will change. So that type of radiation is called unpolarized light. Now there are certain crystal like quartz, etc., which can act as a filter of electromagnetic of all other radiation. So what would happen from a point source electromagnetic wave, light wave is moving in all direction. If you put a quartz crystal, it will move in a definite direction. This is called polarization. This is actually used in the design of the LCD circuits, LCD display. Or what happens, there is a blue LED, some LEDs are there, backlight LED, and in front of that you put a polarizer, it actually filters the light. Now after that you put another analyzer actually, which is at certain angle, so it actually makes the light to move in a definite direction. So in this way you can actually vary the color combination also, you learn it in detail. Okay, so these electromagnetic waves are important, you cannot neglect them. Just like quantum mechanics, all these things or whatever, quantum computation is all about the latest computation and its connected idea. Now, but whatever you do, you have to connect this with our communication engineering, okay? Because this is age of information, you have to send data. How do you send data? Who will take data? The electromagnetic signal we talk about. Now optical fibers are there, light is carrying data, that is the one issue. But for long distance traversing, so enter telephony communication, okay? For long distance traversing, sending data through the air, or suppose light is also passing through a fiber, okay, optical fiber, that is also process of data sending. And you know, through optical fiber, okay, it can carry lot of signals together, lot of channels, okay. So, but at the end of the day, that is also passage of electromagnetic wave through a medium. So knowing electromagnetic wave, its formation, how it passes through a medium is essential. So that's why you have kept it, because you have to learn networking also later on. Where you send the data only, light maybe, because they are mostly optical fibers are used for data signal, data passing. So data will be taken by the light. What is light? Light is basically an electromagnetic wave, with whom you will be adding your information, okay. So all these things are connected concepts. So basically another most advanced, this is, you see the point I was talking about, the modulation now. Unpolarized light, it's a mixture of all the colors you can see there, orange, blue, all these are showing the different planes of vibration of the electric field. Now it can filter out that, you see that quartz crystal. And this beautiful picture is that of a graphene sheet. You know, graphene has got Nobel Prize in chemistry in 2012. So it's the most modern topic. This is 2020. Still people are working a lot. These are called nanomaterials. And this, you know, our entire electronics is becoming nano now, because of that, again, because of Moore, that what your people tried to do, they tried to make each transistor size smaller and smaller and smaller. One day, now days are coming when how small you can be. You have to go below 100 nanometer, and below 100 nanometer is the range of nanomaterial, 1 to 100 nanometer. You learn it in detail, and that is the range of atoms and molecules also. So that's why scientists have developed a technique, you see the picture, where you are using a molecule to act as a device, current is passing, etc., etc. So now people are designing electronic devices using molecule. Okay, so that is nanoelectronics, a beautiful area, and it is a most, again, lot of quantum mechanics ideas are utilized here. You will know it, you will learn it, okay. Entire quantum computing devices are basically nanomaterial devices, where you have to use molecules, the spin of an atom, which will be giving you variety of quantum state, variety of quantum bit. So all these are connected concepts. Wonderful applications are there also. Even as a computer science student also, you can do apply your machine learning technology. People are doing it now. Which possible structure, you see it is rotating, can give you better performance as a device, okay. So you can predict that, and later on through experiments with the people of physics and electronics, we can now realize that. So these are areas where this is the area of interdisciplinary research, okay. If you study, you've got a lot of prospects. You may work in nanomaterials. You can do coding part. You will be working in Unison. And you know, you just imagine there are a lot of electrons involved here. To describe their dynamics, you learn in quantum mechanics. You need to solve a lot of equations. Now, latest compute. You need computing power for that. So there also we have to work together. So it is not, nothing is individual's property. Okay, these are all areas of interdisciplinary work. So what you tried to keep, you have tried to keep the physics too in your course. It is made for you and made for us also. So it's multidisciplinary and interdisciplinary effort. And I hope this will help you a lot. So what shall I do now? I will actually get into the next topic. Actually, that's beginning of the beginning journey. We'll begin our journey of this physics 2 courses, and we'll start with quantum mechanics 2. But you know, there is a problem. Do you know what is the problem? Problem is that if I have to do quantum mechanics 2, you have to remember everything of quantum mechanics 1. Can you remember? Is it possible? I don't think so, because you have learned it almost 8-9 months back, and 8-9 months is a very good time to forget everything. So obviously what I have to do, I have to do a bit of, I have to apply 2 medicines. Medicine 1, what is the medicine 1? Medicine 1 is to make you give some questionnaires to you. Okay, we'll be playing a quiz. So by that you will be remembering all those ABCDs of quantum mechanics 1. And second is that good news. Good news is that I will make it 15 minutes of recap, 15-20 minutes of recap of the major concepts of first year, because some of the concepts, just like I was using a term, the probability wave. I do not know whether you could remember or not now. Okay, some of the concepts are very important today. Okay, so those concepts I want to make you remember. Okay, so first let us go for the test today. Okay, and next class I will first make the remembering part. I will make you remember about, make a brief recapitulation of whatever I have told you in the first year quantum mechanics 1 course. After that we'll move forward. I request you to take patience, and I promise you the days will be very nice and fun. Thank you. Let us meet in the next.